Our universe never ceases to amaze us. Just when we think we've finally unraveled its deepest secrets, it presents us with an enigma so challenging that we are forced to rethink everything we once believed. In a remote region of the cosmos, about 12 billion light-years from Earth, there is something that shouldn't be there. Something that, according to every law of physics we know, simply couldn't exist. This is the story of J2348X7, a technical, unremarkable name for what might be the most revolutionary astronomical discovery of the century. Imagine gazing at the night sky in a place far from the light pollution of cities. Those tiny twinkling lights you see are just a tiny fraction of the stars in our own galaxy. Now, multiply that by trillions. This is the observable universe. An infinite ocean of galaxies, each with its own stellar systems, planets, and perhaps forms of life we haven't even dreamed of yet. Amid this seemingly chaotic vastness, astronomers once believed they had at least one thing absolutely certain: how stars are born. For decades, we taught astronomy students that star formation follows a strict script. First, you need dense clouds of hydrogen. Then, these clouds must collapse under their own gravitational weight, heating up to unimaginable temperatures to kickstart nuclear fusion. Finally, a new star is born. But for this to happen, certain conditions are indispensable, such as the presence of metals, in astronomical language, any element heavier than helium. Without them, the cooling necessary for gravitational collapse becomes virtually impossible. Or so we thought. J2348X7 blatantly laughs in the face of this rule. This primordial galaxy formed when the universe was only 500 million years old. A baby by cosmic standards, contains a concentration of stars that defies any explanation, with a metal content almost non-existent, less than 0.01% of what our models require. It should be a stellar desert. Instead, it is a full-fledged star factory, producing new stars at a rate 100 times faster than our own Milky Way. It all began on an ordinary night in June 2023. Dr. Elena Vasquez wasn't searching for anomalous galaxies when she pointed the James Webb Space Telescope at that specific region of the sky. In fact, she was conducting routine research on the so-called Ryanization era, the cosmic period when the first stars and galaxies began to illuminate the universe after the cosmic dark ages. It was completely accidental. Elena confesses with a smile that mixes humility and astonishment. I was checking the preliminary images and noticed an unusually bright spot in the data. Initially, I thought it was an instrument error. But it wasn't an error. After 3 sleepless nights analyzing and reanalyzing the data, Elena realized that she had stumbled upon something extraordinary. The spectral readings made no sense. They indicated a galaxy extremely poor in metals, yet incredibly active in star formation. She immediately sent an email to her colleague, Dr. Takashi Yamamoto, a specialist in star formation in low metallicity environments. His response was as incredulous as it was swift. "This is impossible. Recheck your calculations." She rechecked 5 times. The results remained the same. When she finally secured additional observation time with the Webb, the image became even clearer and even more perplexing. J2348X7 wasn't just a statistical anomaly. It was a complete challenge to the fundamentals of astrophysics. It's like finding a lush tropical rainforest flourishing in the middle of the Sahara with no water in sight, explains Dr. Yamamoto, now one of the leading researchers in the growing study of this peculiar galaxy. It's not just surprising, it's theoretically impossible. The news spread quickly through the scientific community. Initially, many astronomers reacted with skepticism, suggesting calibration errors or misinterpretations of the data. But as more observations were made using different instruments and methods, the reality became undeniable. The galaxy that shouldn't exist was there, defying our most fundamental theories. Inside J2348X7, something extraordinary is happening. High-resolution images reveal vast regions of hydrogen gas that seem to collapse in ways never before observed. Without the presence of metals to assist in cooling, these clouds should remain too hot to form stars. Yet, they are condensing into new stars at an astonishing rate. One of the most promising theories to explain this phenomenon comes from Dr. Sofia Mendes, a theoretical astrophysicist at the University of São Paulo. "We believe there may be an alternative cooling mechanism at work," she proposes. Perhaps some type of particle or energy field that we have not yet directly detected, something that might be substituting for the role of metals in this process. Other scientists speculate about the possibility of entirely new physics. Maybe the laws of star formation aren't as universal as we thought, suggests Dr. Robert Chen from the Institute for Advanced Studies. This galaxy might represent an alternative regime where different rules apply. But the implications of J2348X7 go far beyond mere academic curiosity. If this galaxy is forming stars without following the established rules, how many other fundamental assumptions about the cosmos might be mistaken? What else are we missing in our understanding of the universe? For Dr. Vasquez, the discovery is a humble reminder of our ignorance. We have spent centuries building elegant models to explain how the universe works, she reflects, observing the mesmerizing images of the galaxy on her monitor. And then, in an instant, nature shows us that our models are nothing more than crude approximations of reality. The impossible stellar nursery of J2348X7 is generating more than just stars. It is sparking a revolution in astronomical thinking. Research teams around the world are now re-examining old data, searching for signs of similar phenomena that might have been overlooked. Computer simulations are being rebuilt in an effort to reproduce the conditions observed in this anomalous galaxy. One of the most intriguing discoveries emerged recently when astronomers managed to identify individual stars within J2348X7. Using advanced imaging techniques, they noticed that many of these stars appear to be exceptionally massive, blue, giants with more than 100 times the mass of our Sun. These stars live fast and die young, exploding as supernovae after only a few million years. It's as if this galaxy is operating in turbo mode, explains Dr. Anaya Patel, an expert in stellar evolution. It not only forms stars where it shouldn't, but predominantly the largest and most powerful ones. These frequent supernovae, in turn, create an even more peculiar environment. When these massive stars explode, they send shockwaves through the surrounding interstellar medium, potentially triggering even more star formation, a cosmic domino effect. More surprisingly, they begin to enrich the medium with heavy metals forged in their cores. Essentially, J2348X7 seems to be building its own star formation mechanism from scratch, initiating a cycle that will eventually transform it into a normal galaxy by our standards. It's like watching galactic evolution in real time, marvels Dr. Yamamoto. In cosmic terms, it's like going back in time and watching the first fish crawl out of the water to become amphibians. It's a missing link in cosmic evolution. Beyond the scientific implications, there is something profoundly poetic about J2348X7. This galaxy reminds us that even after centuries of observation and theorization, the universe still holds surprises that can leave us in awe. It reminds us that reality often surpasses our imagination, that nature finds ways where we see no possibilities. The impossible stars of J2348X7 shine across billions of light years, traversing nearly the entire history of time to deliver a simple yet profound message: there is still so much to learn. Every answer we find generates 10 new questions. Every horizon reached reveals even more distant ones waiting to be explored. And perhaps that is exactly what makes astronomy so irresistibly fascinating. It is not just a science that studies distant objects. It is a continuous journey of self-discovery. In gazing at the impossible stars of J2348X7, we are not just looking at a peculiar astronomical phenomenon. We are looking at the limits of our own knowledge, at the boundaries of our understanding of the world. Dr. Vasquez, who now leads an international consortium dedicated exclusively to the study of this galaxy, sums up the sentiment that many of her colleagues share. In science, our greatest discoveries rarely come from confirming what we already know. They come from those bewildering moments when the universe tells us, "You haven't fully understood yet." And J2348X7 is screaming that to us. As we continue to observe and study this impossible stellar nursery, one thing is clear. The universe has just become much more interesting and much more mysterious. The stars that shouldn't exist are shining, silently defying our certainties, inviting us to reimagine the cosmos and our place within it. And who knows what other impossibilities are waiting to be discovered in the infinite depths of space. J2348X7 may be just the beginning of a new era of discoveries that will fundamentally transform our understanding of the universe. A universe that, apparently, still has many cosmic tricks up its sleeve.